All right, here's our video for day 2 of the parabola notes. Today what we're going to be doing is writing equations from given information. Yesterday we graphed from an equation. Today we're going to be ending with an equation. So in this first example right here, we're given the vertex and a directrix. And that actually is enough information to come up with all the other things that we need to write our equation. So I like to say you don't have to have your master plan ready to go as soon as you start working. Just start with your given information and then plan your next step from there and see where it takes you. So if I'm just starting with my given information here, I would do this. Graph my vertex here at 0, 0, and my directrix at y equals 2. This is a horizontal line where every point has a y value of 2. So that's up here somewhere. Now, believe it or not, just these two things let me know pretty much everything else that I need. So if our directrix is at y equals 2 and the parabolas open away from the directrix, then I can tell from this drawing that my parabola is going to be opening down because it'll be opposite from this line. And it can't be going left or right because then it would cross that line, and it can't be going up for the same reason. Now, once I know this, I know which form of general equation I need. If you looked at your formula sheet, the up or down orientation is this general equation. This is for up or down. And then a left and right orientation is where you take this group that has x and h and this group that has y and k, and you just switch their positions. And this makes a left or right orientation. Okay. So now to complete this equation, we need three things. We need the h, p, and the k values. X and y are going to stay x and y. So I can get the h and k from the vertex. This is my h, this is my k. That part's done. So what I have left to find is the p value. So there's a couple of things I want to bring to your attention here. The p, the absolute value of p, is the distance from the vertex to the directrix and from the vertex to the focus. Those lengths are both the absolute value of whatever p is. Well, we know by just counting the space between here and here, because this was our directrix at y equals 2. At my vertex here, y is 0. So this is 2 spaces from here to here. Right? So that's the absolute value of p is 2. But the actual value of p that we're going to substitute in our equation is going to be negative. And we know that because this is opening down. A downward opening graph gives me a negative p-value. An upward opening gives me a positive. So similarly over here, a parabola that opens to the right is going to have a positive p-value, and a parabola that opens to the left is going to have a negative. So now I have, in this problem, all the information I need to substitute in here. So h is 0, p is negative 2, k is 0, and I'm just going to simplify this. X squared equals negative 8y. So I want you to pause the video and try this next problem. Notice how the directrix is x equals 4. That's a vertical line through 4. So since our directrix is going up and down now, our parabola will be opening left or right, and we'll use this equation. So pause the video and try that. All right, here's my work for this problem. My directrix is here, x equals 4. My vertex is at 0, 0. The absolute value of the distance, or my p-value, is 4, because from this point to this directrix the length is 4. The parabola will be opening to the left because it's going away from the directrix. Since it's opening to the left, my p-value is going to be negative. So my final answer is going to be a negative 16x, and then I have y squared on the left. All right, this next problem gives us the vertex and the focus. So I'm going to start by drawing it again. My vertex is at 0, 0. This time the focus, not the line of directrix, is what's given. And so that is going to be here. So this is my vertex, this is my focus. Now that's enough information to know which way it opens, because we know that the focus is in the interior of the parabola. So it's going to be opening to the left, which means its directrix is somewhere over here. And we know that this distance right here between these two is 2, because I have to go 2 spaces to the left to get here. And because it opens to the left, my p-value is negative, and my h, k are 0, 0. So since this is a left-right orientation, we use the formula where the y value is squared. And then we plug in our values. 0 for h and k, negative 2 for p. So this gives me y squared equals negative 8x. So you pause your video and try this next one. All right, here's my work for that problem. X squared equals 12y. Pause the video if you need to compare yours to mine. All right, on this bottom section, we're being given 2 standard form equations. We are going to rewrite them in one of these vertex form of equations. We're going to do that by completing the square, which is a skill we talked about last week. But I want you to add some more to these instructions. I want you to add completing the square to rewrite the parabola in vertex form and identify the key features. So by key features, I mean the vertex, the focus, the directrix, and the axis of symmetry. All right, so I'm going to do this one for you and then ask you to pause the video and try the second one. So in this first one, we can tell that the x squared is our term that determines which facing, okay, Miss Claudia's talks, take 2. This is an x squared situation, so we're going up or down with our parabola. This one over here is a y squared situation, so we're going left to right with our parabola. So to start completing the square here, I group my x terms. I take the b value and divide by 2. That gives me negative 4. And then I'm going to square that and get positive 16. I'm going to add that inside this group, and then I'm going to subtract it outside the group. That will keep my left side balanced. So x squared minus 8x plus 16 inside the group, and then minus 16 here outside the group. So then we want to rewrite this group as a binomial squared, because remember, we're working towards this form of an equation. Binomial, so 2 terms squared equals some number times y minus another number. That's our goal here. So you can rewrite this using factoring, what multiplies to the last term and adds to the middle. And it's negative 4, negative 4. Remember, though, we're trying to write it, so this is true, x minus 4, but we're trying to write it like this. X minus 4 quantity squared And then we had the shortcut that whatever number you get here when you divide by 2, that's going to be the same number that goes here in your factored form. And then 16 and negative 16 cancel, leaving me negative 8y equals 0. Now our equation that we're working towards, this squared binomial is by itself on the left, and the y to the 1 value is on the right. So to get that here, we're just going to take the negative 8y and move it over by adding it. So x minus 4 squared equals 8y. So here's my equation, and I'm going to use this to find the other information that I need. I want the vertex, the focus, the equation for the directrix line, and then my axis of symmetry line. So the vertex is easy to read. It's 4, and then there's no minus k over here, so we know it's 0. So I'm going to go ahead and graph that. 4, 0, that's my vertex. And then it appears that I'm stuck. I have a vertex, but the graph could go up, down, left, or right from that vertex. So what we need to figure out its orientation is our p-value information. So if you remember from the last lesson, we find the p-value by taking this constant term, 8, and setting it equal to 4p. So I'm going to do that here. So 4p equals 8, which means p equals 2. Now I have two pieces of information from that. One, it's positive, so I know that my graph will be opening up. And I should have said a second ago when I said there was 4 different directions it could go from here, because I already had this equation, that is narrowed down to 2 directions. Because it's an x squared situation, I know it's either going to open up or open down. So I misspoke when I said there was 4 possible ones. There's just 2, up or down. And now that p is 2, we know it's going to be going up. It's going to be opening in the positive direction. And we know that this absolute value of p is positive 2. That means I go up 2 places to get to my focus here, and down 2 places to get to my directrix here. So if my vertex is 4, 0, and I'm going up 2 to get my focus, that means my y value is changing by 2 this way. And if I'm going down 2 to get to the directrix, that's a horizontal line where all the y values are equal to negative 2. So y equals negative 2. So my focus is 4, 2. My directrix is y equals negative 2. Now I'm using a drawing to figure those things out. You are free to use your formula sheet because you know your HK and you know your p-value, and that in your formula sheet uses those. And then the axis of symmetry goes through the vertex. That's a horizontal line that goes through x equals 4. I know it's 4 because that's the x coordinate of my vertex. And so there's the axis of symmetry. So I want you to pause the video and try the second one. Okay, so I have some of this work covered up because I am anticipating that you might have gotten stuck here. Y, or maybe even here. You completed the square, you have y plus 3 quantity squared minus 4x plus 8. So this isn't just a constant, this is 2 terms. But we still want them to be on the right side of the equation because we want this binomial squared all by itself. So I do the opposite of each thing and I get it on the right. So now remember, we're working towards 4p times parentheses x minus a value. So to get this in that form, I'm going to take a GCF of 4 out. So 4 parentheses x minus 2, you can test that with distributive property. So that's a factoring method of greatest common factor. And then once we get it in that form, we can finish out our problem.